Hi Applied Max students, welcome to our channel Max Plus U. Today, integration and its application, student support material, CBSE Handbook Part 8 we are doing children, and the topic is integration by parts or Bernoulli's formulae. So integration by parts, why we are using? When two functions are there in multiplication. How in differentiation we will use no children, uv the whole dash we use no. Like that way only, but here some differences there. What and all difference we'll use to see? See, integral u dv equals to uv minus integral v du. First difference, in the product rule we will say uv, but here u dv. So that you have to understand. Then what and all I will tell you. See, the integral of the first, the integral of the product of two functions. Two functions you are going to multiply is there in the product and you are going to integrate now. First function u, okay, then integral of the second function. That means usual second function we are not taking, integral of the second function. That means dv is a second function now. dv you going to integrate, that is nothing but v. Somewhat understood ma? So first function into first function u, then not integral of the second function in the sense dv integral is v, so uv minus integral of the product of the derivative of first function and integral of the second function. Product now multiplication, derivative of the first function is du, u differentiation is du, and integral of the second function is v. Clear? Check. Then some rules. No particular rule for choosing a function out of the two given function. Which is u, which is dv. Like that we are not having any particular rule in the first or second. But for easily, which is easily differentiable, that should be taken as a first function. And the second function should be such as its integral. So that's way only they are saying. But most of the condition this is works. What is works? I late. I means inverse trigonometry. First inverse trigonometry comes on that first, then logarithmic function, then algebraic, then trigonometric, then exponential. But for us only LAE. Why for applied math students only LAE na? Inverse trigonometric. Trigonometric itself not there. Then what inverse trigonometry? So trigonometry and inverse trigonometry not there na. Log, algebraic, exponential. These three only was there for us. So as we discussed already, integrate by parts, we have another formula, that is Bernoulli's formula, integral u dv equals uv minus u dash v1 plus u double dash v2 minus u triple dash v3, like that, plus minus plus minus plus, like that it will goes on. We'll discuss it children. As we already said, LAE only we are explaining here. Logarithmic function, algebraic function, exponential function. Now exercise 3.3 pa. So we are doing the first one, integrate the following function. So u, since this is like algebraic, exponential is e, by you I'm just using LAE itself. So algebraic is u and exponential is dv. So make sure one thing, u and dv, and in the u part you're going to differentiate, and the dv here you're going to do integrate. Nice, no children? One place differentiation, one place integration. Now we have taken u as x, dv as e power 2x plus 3. So the u we are differentiating with respect to x. So du by dx is 1. Division dx goes at sign of multiplication. So de equal to dx. dv we are integrating children. E power 2x plus 3 integration. We all know e power x integration is e power x, and e power 2x integration na e power 2x by 2. Same way e power 2x plus 3 integration is e power 2x plus 3 by 2. Then apply integral u dv, uv minus integral v du. U value x ma, then v value e power 2x plus 3 by 2. Integral v is e power 2x plus 3 by 2. du is what ma? Dx. Now just say children, it's somewhat easier for us. What is easy? Just write x e power 2x plus 3 by 2. Then this by 2 half you have taken out. E power 2x plus 3 again integrate. Like how you are said before, e power 2x plus 3 integration is e power 2x plus 3 by 2. 2 2s are 4 children. So x e power 2x plus 3 by 2 minus e power 2x plus 3 by 4 plus c. Easier c ma. uv minus integral v du we just playing. That's it. Aliter method. What is aliter method? Na? When aliter is just a particular case. When the algebraic function and exponential comes na alone, we can use it. Algebraic and logarithmic we can't use. So the u y na, if I consider here u as x, I will get u dash as 1 and u double dash as 0. At a point of time it will stop. You see, as per the formula it will goes on. So if it is some other term like a log x, we consider u na, where you will stop. So in that sense, always what algebraic and exponential comes now only, we have to take this Bernoulli. And also x e power 2x plus 3 actually easy when even you can do integrate by parts. But when the preferably instead of x square, x cube, x power 4 like that and all comes, Bernoulli's is advisable. Okay, anyway, even x e power 2x plus 3 also we can do it. It is easy. U is x, x differentiation u dash 1, u double dash 0. So till 0 we are going to do. So till before that, till u dash our formula needed. Same way, dv equal to e power 2x plus 3. We have to integrate here. Integral dv is v. E power 2x plus 3 integration same. That no change. E power 2x plus 3 by 2. E power x integration e power x. E power minus 3x integration e power minus 3x by minus 3. So we are differentiating the 2x and we are writing in the denominator. Differentiation na, we will just multiply e power 2x plus 3 into 2 we will do. In division we are doing the 2 in the division. In the integration we are doing in the division. So we got it as e power 2x plus 3 by 2. Again e power 2x plus 3, this 2 we are keep as it is. Again 2x differentiation is 2 that we are writing in the denominator. So v1 is e power 2x plus 3 by 4. Why sir we are stopping in the v1 na? Since we are have only till u dash. So we are stopping in the v1. U double dash we have value na. Till v2 we have to do. Till u triple dash we have value na. Till v3 we want to find. Clear check pa. Then integral u dv. What is the Bernoulli formula? uv minus u dash v1 plus u double dash v2. Like that it will goes on. I think for us this 2 is enough. Because v2 is nothing but 0. Start applying children. So what you will get it? You will get it. U value is x. V is e power 2x plus 3 by 2 minus u dash is 1. V1 is e power 2x plus 3 by 4. That's it. Plus c. Since it's indifferent integral, plus c is mandatory. Easy amma. Just applying formula ma. uv minus u dash v1. So we got the next one. So here we have to use only integrate by parts because logarithmic is there. X square plus 1 we are considering it as a t children to take the chain rule. X square differentiation is 2x, 1 differentiation is 0, t differentiation is dt by dx. Division dx goes inside na multiplication. So 2x dx is dt. Then x dx ma multiplication 2 come this side na division. So x dx equals to dt by 2. Now apply children. So what and all you have to apply? Log x square plus 1 place you have to apply t Then x dx, x and dx together, that place you have to apply as dt by 2. So we got like I equals integral log t into dt by 2. This by 2 you keep outside. So 1 by 2 if you keep outside na log t dt. So the log t alone, how sir we will integrate na log t into 1 or log x into 1, like that you have to consider. So sir, 1 and all algebraic sir? Yes. Log x we consider it as only one function. We are splitting log x into 1, log t into 1. Since log t into 1, log will consider as logarithmic function, 1 will consider as algebraic function. 1 x power 0 or 1 t power 0. We can able to write, no? So in that way it is algebraic. So u is log t and dv is 1 dt. So you are differentiating u with respect to t, du by dt, log differentiation, log t differentiation 1 by t. Actually we are differentiating. Here we are doing integration, integral dv equals to integral 1 dt. So integral dv is v, so 1 integration is t. Clear? Check. Then we are applying integral u dv equals uv minus integral v du. So what and all we are keeping it out of, already keep it out children. So uv, u value, what is u value? Log t, v value t minus integral, again v is t and du is 1 by t dt. Then any cancellation possible, I have to check. The tt cancel and you will get 1 dt. 1 if you are integrating na, with respect to t, you will get it as t. So I equals to 1 by t 1 by 2 times t log t minus t plus c. Clear? Check children. So after sum over a sir na, no, we should substitute the t value here. T is this t we have written here actually. This log t is x square plus 1. Again minus t value is x square plus 1 plus c. Then anything we can take out, you have to see children, here 1 x square plus 1 and here x square plus 1. So x square plus 1 by 2. So already 1 by 2 is there. So x square plus 1 if we kept outside now, we are getting it as log of x square plus 1 minus 1 plus c. Clear? Check. Then the third subdivision, I equals integral x square e power x dx. What is u? What is dv? U is x square, dv is e power x. Differentiate u with respect to x. Du by dx ma, x square differentiation 2x pa. Division dx goes, it's a multiplication. So du is 2x dx. Then integral dv equal to integral e power x dx. So integral dv is nothing but v. E power x integration is e power x. Integral u dv equals to uv minus integral v du children. Same, easy pa. U value x square, v e power x. And here around you have work integral v is e power x and du is 2x dx. So 2 we can keep outside children. And we got again x e power x dx. So we going to do the, what we going to do? We going to do the again integrate by parts. For that only like this x square, x cube and all comes now, we will prefer Bernoulli's. Anyway, Aliter method we will do Bernoulli also. No issues. Again you going to use the integrate by parts. U is x and dv is e power x dx. X differentiation 1. So division dx goes, it's a multiplication. If you are integrating v, good news is e power x integration e power x. Even e power minus x suppose was there also, it will change e power minus x by minus 1 like that. But fortunately it's e power x only, so no change. So apply uv, already x square e power x was there. So now what you're doing, my x square e power x and minus 2 is default. Only x e power x we are integrating. Am I correct children? So this till this already was there. U x v e power x minus integral again v e power x du dx. So e power x dx we are getting, e power x integration is e power x plus c. So anything we can take common. You can stop here children, there is no doubt in it. If you can just multiply and you can stop, or you can take e power x as common. X square minus 2x Then minus into minus plus. So in that way plus 2 plus c. Did you understand how x square minus 2x plus 2 coming? Because we are taking x square. That means e power x as common. E power x take x square. Again e power x take minus 2x. Again e power x take minus 2 into minus 1 plus 2. Clear, check. Sir, I will use Bernoulli's formula. Okay, Vasana. Yes, we can use Ariton method. I just want to show here. U is x square. dv is e power x dx. So x square differentiation 2x. Again 2x differentiation 2. U triple dash 2 differentiation 0. So triple dash not necessary. Then integral dv. So easiest one is e power x integration is e power x. Even e power x differentiation is e power x only. The same way, again e power x differentiation e power x. Why is that till v1 we want to do? Actually till v2 also we need. v2 also actually e power x. Here u double dash not till v2. U triple dash not till v3. But here e power x integration is e power x only. So till it was easy. Okay, apply Bernoulli's formula. So till v2 we are applying. What is the formula, ma? Integral u dv equals uv minus u dash v1 plus u double dash v2. Actually minus u triple dash v3 will come, but u triple dash is 0. Am I correct, children? So 0 into anything 0. So only this 3 is enough. So what is the advantage of doing this formula? No? Just writing uv minus u dash v1 plus u double dash v2, like that once itself we are completing. Just e power x is common and you will get x square minus 2x plus 2. So 2 times we don't want to do it. Once we'll apply, again we will do it. Again we have integral like that and all. That is the only advantage of doing Bernoulli's. Okay, going for fourth subdivision, ma integral x log x dx. U is log x. Differentiation of log x du by dx is 1 by x. du equal to 1 by x dx. Integral dv equal to x dx. So you know, children, log x comes now that you will take u and dv is x dx. I hope you know. I let L A E logarithmic, algebraic, exponential. So x integration is x square by 2. Clear, check. Then apply, children, integral x log x dx equals uv log x into x square by 2 minus integral v du x square by 2 into 1 by x dx. So any chances? X square by 2 into log x we are writing. X and square cancel na, integral 1 by 2, this 2 keep outside, 1 by 2 integral x dx. Just integrate the x, children. X integration is x square by 2. So x square by 2 log x minus 1 by 2 x integration is x square by 2 plus c. I think we can just multiply the 2. 2 2s are 4. So x square by 2 log x minus x square by 4 plus c. Easier, check, ma. Same way only, ma. But instead of log x, we have log 2x. So since logarithmic function LAE log we have to consider as u and dv we have to consider as x dx. Make sure dv. Sir, product rule I have taken uv, so u and v like that don't take. Always integrate by parts when you are doing dv. So dv is x dx. So differentiating log 2x means 1 by 2x, then 2x differentiation 2, 1 by 2x into 2. Then we are integrating dv less. So integral dv equal to integral x dx. So integral dv is v. X integration is x square by 2. Then what is the formula now? Integral u dv equals uv minus integral v du. As usual, apply, children. U is log 2x and v is x square by 2. Integral v is x square by 2, then du is 1 by x. We can cancel and x and x. The 2 we can keep outside. Again we got integral x dx. Once we got integral x dx now, then x integration is x square by 2. Then 2 2s are 4. We got I equals x square by 2 log 2x minus x square by 4 plus c. Then sixth subdivision ma, x square log x dx. Again LAE log only we have considered as u. Then dv we wanted to consider it as x square because logarithm x comes first. So differentiating log x du by dx with respect to x, log x differentiation is 1 by x. Dv we have to integrate here and make sure again u dv, u is x square, dv is log x dx, and u side you're going to differentiate and v side you're going to integrate, remember. So 1 by x division dx goes, it's in a multiplication, du equal to 1 by x dx. We are integrating dv children, so integral dv is v, x square integration x power n plus 1 by n plus 1. So x power 2 is there now, x power 2 plus 1 by 2 plus 1. So x power 3 by 3. Then apply integral u dv equals uv minus integral v du. U is log x, v is x cube by 3 minus integral v is x cube by 3 du is 1 by x dx. And then that x and x cube, if it gets cancelled now, we will get it as x cube by 3 log x minus 1 by 3 x square. Once x square we are integrating now, what will come? X square integration is x cube by 3. Then if we got x cube by 3 log x, the 3 you multiply children, minus x cube by 9 plus c. So I equals to x cube by 3 log x minus x cube by 9 plus c. Clear? Check. Then seventh subdivision children. So we have again log only. So logarithmic function comes now, and x square plus 1 is algebraic. So we should take, we are taking u as log x and dv as x square plus 1 dx. As usual, differentiate log x ma. A log x differentiation 1 by x. Division dx goes the same multiplication. Then you have to integrate the dv. So x square plus 1 dx is going to integrate. X power 2 integration is x power 2 plus 1 by 2 plus 1 x power 3 by 3 by using the formula. Then one constant integration, constant into x, so 1 integration 1x x. Integral u dv equals uv minus integral v du. U is log x times v is x cube by 3 plus x minus integral v is x cube by 3 plus x into du is 1 by x dx. Then what now? We going to multiply the 1 by x each. X cube by 3 into 1 by x, then plus x into 1 by x. This x and x gets cancelled 1, and this x and x cube gets cancelled x square. Clear? Check ma. So minus integral x square by 3 plus 1 into dx. So then what pa? The same thing we'll write log x into x square by 3 plus x minus just outside, minus is keeping outside, 1 by 3 I am keeping ma. X square integration is x power 3 by 3, x power 2 plus 1 by 2 plus 1. 1 constant integration 1x. Clear? Check. So I equal to log x times x cube by 3 plus x minus x cube, 3 3s are 9 ma. Minus 1 into x is minus x plus c. Clear? Check. Easy children. Eighth one, I equals to integral x log x the whole square dx. How to do here now? As usual, u is log x the whole square, then dv is x dx. So we all know x square differentiation 2x, so log x the whole square differentiation is 2 log x, then log x differentiation is 1 by x. Then you're going to integrate the dv, x integration you want to find. So the x integration is x square by 2. So 2 log x by x. Division dx goes the multiplication, so only got here. As usual, integral u dv equal to uv minus integral v du. So apply u is log x the whole square, then v is x square by 2 minus integral, again v is x square by 2, du is 2 log x by x. So the 2 gets cancelled, and x and x square, one x gets cancelled. Then we got like this, I equals x square by 2 log x whole square minus integral x log x dx. So again you are going to do integrate by parts. U is log x, dv is x dx. So you have to do the log x differentiation, du by dx 1 by x, division dx goes it's multiplication 1 by x dx. Then integral dv integral x dx. So integral dv is v, x integration is x square by 2. We all know integral u dv formula, uv minus integral v du. Then u as usual x square by 2, then v is log x whole square minus integral. So this is actually as it is like x square by 2 log x whole square. For this only uv. U is the log x, v is x square by 2 minus integral v du, x square by 2 into du is 1 by x dx. So again x and x square gets cancelled. Now we are getting it as x value children here. So what we want to do for that x integration now, x square by 2. Clear, check ma. Then the next step you have to multiply the minus inside, minus x square by 2 log x. Then again minus inside, minus into minus plus x square by 2 2s are 4 plus c. Clear, check children all of you. So it's easy only, properly of doing now. Then the second one we're going to do integrate by parts. Actually we have done it, but anyway another one formula we will use to do it, that is integral e power x f of x plus f dash of x equals e power x f of x plus c. What are f of x plus f dash of x? Here one function is there. Okay, so that differentiation is supposed to get here. For example, here x square na, here 2x. Integral e power x should not be. So that sense it is there now. We can get like that. So as I said here, easiest sum I equals integral e power x into x power minus 2 minus 2x power minus 3. So x power minus 2 we had considered as f of x, so that you differentiate f dash of x, nx power n minus 1 minus 2x power minus 3. So we are getting it as the formula e power x f of x plus f dash of x equals e power x f of x plus c. So e power x f of x is x power minus 2. We know children a power minus m is 1 by a power m. So e power x by x square plus c. Then e power 3x. So 3x we are considering as t na, x differentiation 1. So 3 into 1 equals t differentiation dt by dx. Division dx goes it's a multiplication. So 3 dx equal to dt. So d, what is the dx value if you considering now? Multiplication 3 comes here na division. So dx is nothing but dt by 3. So I equals integral e power, the 3x place we are can keep t children. Then log 3x na, log t. That 1 by 3x dx is there. That means that that place only we are going to keep it properly. So what we are going to keep now? 3x t e power t. Log 3x log t. 1 by 3x is there no. So what is 1 by 3x? Going to reciprocal the 3x. 1 by 3x. So t by 1 going to make it as 1 by t. So 1 by 3x is nothing but 1 by t, or 1 divided by 3x plus t. Why we want to go complicate in that sense? 1 divided by 3x plus what? T. So 1 by t. Then we have 1 by 3 is already outside. How 1 by 3 outside now? dx value is dt by 3. Correct, children? Dx is dt by 3. That dt by 3 only we are writing here. Then the division 3 come outside now. 1 by 3 integral e power t log t plus 1 by t. So log x we consider f of x now. F of x log x differentiation is 1 by x. So directly we can apply the formula e power x. That means f of t. This time not x. F of t is log t. F dash of t is 1 by t. So e power x f of x plus f dash of x dx equals e power x f of x plus c. So e power x in that place is e power t. Already 1 by 3 outside. F of x is log t. Children, as we already say, so we should not stop here. We should apply the value of t. T plus 3x e power 3x log 3x plus c. Clear a check mark. Now third subdivision. Integral e power 2x minus 1 by 4x square. So 4x square we can write it as a 2x whole square. First that is clear a check. Then once we have written this, we can take 2x as t. Differentiate, children. 2 into x differentiation 1. T differentiation dt by dx. Division dx goes as multiplication 2 dx equal to dt. Dx equal to dt by 2. Integral e power 2x plus t ma. Again 2x plus t ma. Minus 1 by t square equals. Not equals dt by 2. Dx is dt by 2 this time. Understood ma? So what and all we are applied? Wherever 2x is there and all t pa. That's it. Dx alone dt by 2. Then this 2 you keep outside. 1 by 2 e power t. The t minus 1 by t square is there, no children. We can divide it separately ma. T by t square minus 1 by t square. So the t and t square t gets cancelled. And we got like that e power t 1 by t minus 1 by t square. Like 1 by x integration. 1 by x integration what pana? Minus 1 by x squared we have applied as one formula. How sir we got na? 1 by x as x power minus 1. You just apply. Actually you're doing in differentiation, no? Since 1 by t differentiation. So x power minus 1, nx power n minus 1, minus 1 x power minus 1 minus 1, minus 1 x power minus 2. That is nothing but minus 1 by x square. So f of x is 1 by t. F dash of x is minus 1 by x square. So here instead of x is t. So f of x 1 by t now. F dash of x is minus 1 by t square. Same formula ma. E power x f of x plus f dash of x equals e power x f of x plus c. So 1 by 2 outside. X is t, e power t, f of t is 1 by t dt. Plus c is mandatory ma. Then wherever t is there, t place apply 2x children. 1 by 2 e power 2x times 1 by 2x plus c. Clear up? Then the last sum in this exercise, I equals integral log of log x plus 1 by log x the whole square dx. Children, since the log x comes twice, can we take log x as t pa? So log x is t, we can differentiate log x as 1 by x, t differentiation dt by dx. Division dx goes as a multiplication, so 1 by x dx is dt. Then x, the log goes inside now, so x equals e power t. Dx equals to, what is dx? Here, this division x goes inside a multiplication, so dx equals to xe dt. The x value we got here. How sir x equal to e power t? Like that na. Log term goes that side. That is it will be exponential. Same way e power t equal to x is there na. The e we can keep here na. It will become log x equals t. Clear check pa. So instead of x e power t we applied. And we got here I equals log t plus 1 by t square into e power t dt. So just multiply the e power t inside ma. Integral e power t log t plus integral e power t into 1 by t square dt. That means I equals I1 plus I2. So take I1 as integral e power t log t. I1 as integral e power t log t dt. So u is log t and dv is e power t dt. So log, if you're differentiating log du by dt, log differentiation is 1 by x. Log x na 1 by x, log t means 1 by t. Division dt comes inside now. Du equal to 1 by t dt. Then dv e power t dt, you are integrating dv now, it will get v. E power t integration is e power t. Integral u dv equals uv minus integral v dv. So I1 we are doing separately, I1 I2 like that separately we taken. So in that u is log t, v is e power t minus integral v is e power t, du is 1 by t dt. So the e power t 1 by t we going to integrate it again. So how we are doing? U as 1 by t, dv as e power t dt. So 1 by x differentiation minus 1 by x square. So du by dt is minus 1 by t square. Division dt goes with sign of multiplication. So integral dv. So we are integrating the dv. It's nothing but v. E power t integration is e power t. So I1, already these two we know children. Log t e power t outside. Then again uv, u is 1 by t, v is e power t minus integral v du, v is e power t, then du is minus 1 by t square dt. So the minus you multiply inside, minus 1 by t e power t, minus into minus, plus again plus into minus, minus. So we got minus integral e power t into 1 by t square. Sir, again we want to integrate like that, don't think, because in I2 also we have the same thing. What we have? E power t into 1 by t square dt. So if you just substitute it, both will get cancelled. So we don't want to do it again. That you wanted to note ma. If you are splitting as I1 and I2, we have to be careful when we are doing it. Otherwise, don't split I1 I2, directly integrate. Okay, I equals I1 plus I2. So I1 value fully we written till this is I1 value. Till which is I1 value? Till this. Log t e power t minus 1 by t e power t minus integral e power t into 1 by t square dt. Then the I2 is e power t into 1 by t square. So anything have a chance of getting cancelled as sigma. Minus and plus gets cancelled. So log t e power t minus 1 by t e power t. So we are taking e power t as cancel common ma. Then log t minus 1 by t plus c. Sum over or you want to apply t or not? Definitely we should start applying t value. So instead of t log x you apply children. So e power log x, log of log x minus 1 by log x plus c. Clear check children. So after kindly do the practice sums. The first two one in the what integrated by parts are Bernoulli. I think first you can do it. It is easy only. Then the second one by using integral e power x f of x plus f dash of x. Kindly forward to applied maths students. It will be useful for them. Thank you.